The de Broglie wavelength arose from the concept that electrons have wave-like behavior, just like electromagnetic radiation has particle-like behavior. Okay, and so basically this de Broglie wavelength, this is derived equation for the wavelength of any particle of mass m. Okay, for example, a planet. So we can get the wavelength of a planet, a baseball, or one of those electrons. Okay, and so this is due to the fact that matter has wave-like properties. Okay, behaves as though it moves in a wave. And the wavelength is inversely proportional to mass. Okay, and so what does this equation look like? All right, so basically we've got a derivation here where we've got our energy with our hc over lambda, or an energy is mc squared. And so in these situations, we have used the speed of light because we're talking about electromagnetic radiation. But now, when we look at the speed, we change to velocity so that we can account for the velocity of the object, not the speed of light. Okay? All right, so let's try this. So I've got a golf ball moving at 30 meters per second. Okay, this is good. We have kilograms because remember, joules have kilograms in the unit. Okay, and H is our Planck's constant. So we can do our de Broglie wavelength, and I put the equation down there. We're going to take our 6.626 times 10 to the negative 34th. Okay, kilogram meter squared second. Okay, the mass is our 0.072 kilograms, and then we have 30 meters per second. All right, and so when we do this, we get 3.07 times 10 to the negative 34th meters. Okay, is our wavelength for our golf ball. All right, so here's another one. We've got an electron that has a speed. I've put Planck's constant and the mass of an electron on there. So I want you to try this one on your own. You should get 7.27 times 10 to the negative 10th meters. Okay, and that's our de Broglie wavelength. Because again, if our electrons, which are particles, have wave-like behavior as well, then we can take any object that has mass and assign it this wave-like properties and calculate a wavelength. So try it for the electron.